Hey guys, we're going to be doing a lesson on Carnegie Learning. We're going to have a part one today and then a part two the following day. But just a reminder, I will put the link in your assignment for today. But when you get to this, when you click on the link, you're going to see this. Remember to sign in with ClassLink. Once you do that, it will sign you automatically in. Don't put your username or password in. Okay, so what you're going to need today is you are going to need your math journal. I have assigned the assignment for today. You will see that, and you will be completing part of the assignment today. I will tell you exactly where it is that you would stop. But you are going to need your math journal, and as we go through this, I'm going to be doing some of the questions in there, but the rest you'll be doing by yourself. So I would also have your Texas Home Learning up, or sorry, your Carnegie Learning up, so that you can complete the ones that we're doing in the lesson as we go, but then you're also going to have some to do by yourself, and you'll turn that in. That's going to be your assignment today. Okay, so for our warm-up, what I would like you to do is we have a list of numbers here, and maybe if it loads, but you're going to have a list of numbers here, and what I want you to do, I want you to hit pause, and I want you to go ahead and on a piece of paper, in this array of numbers shown, you're going to circle the prime numbers, cross out the composite numbers, and use a box to identify any number that is neither prime nor composite. So go ahead and pause right now and complete this. Once you have finished, you can go ahead and hit play and check your answers because we're going to go over this. All right, so hopefully you paused. I am going to scale this back so that I can write with my pen. So let's talk about what prime numbers are. Prime numbers are the only factors that it would have are 1 in itself. For example, 1 times 3, those are the only factors of 3, 1 and then the number itself. We cannot multiply any other factors to get an answer of 3. Another example would be 2. 2 times 1, those are the only factors, 1 and 2 of 2. But if we do 4, we can do 1 times 4 and we could do 2 times 2. Because we have more than one set of factors, that makes it a composite number. So we're going to go ahead and we're going to circle the prime numbers first. So you should have circled 2, you should have circled 3, you should have circled 5, 11, 13, 17, oops, sorry guys, 13, 17, and then 19. So those are all of our prime numbers, that the only factors would be 1 and then the number itself. Then what we're going to do is we are going to cross out all of the composite numbers or put an X on it. So those would be everything. Oh, you know what? I forgot to circle 7 too. Sorry guys, that should be circled in 7. Everything else have more than one factor. Now, 1's a little bit tricky, but 1 is actually considered relatively prime. Okay, so 1 is the exception, and that is relatively prime. So that should be your warm-up. So we have circles around our prime numbers, and we have crossed out our composite numbers. All right, so the next thing that we're gonna do is we are going to go back to this. We did our warm-up. So we're going to talk about our learning goals today. So our learning goals today, if they load, so we're going to identify the factors and multiples of numbers and the common factors and multiples of two whole numbers. We're going to use powers and exponents to write prime factorization of a number, and we're going to write and to evaluate numeric expressions using the distributive property to model composing and decomposing rectangles, the areas of them, and we're going to rewrite the sum of two whole numbers with the common factors of product using that distributive property. All right, so those are some things that we're going to be doing, and our key factors today are common factor, greatest common factor, and sometimes we say that it's GCF, greatest common factor, relatively prime, multiple, commutative property of multiplication, and our least common multiple. So what you're going to do real quick is I want you to pause again. And we're going to create area models for the number 16. Okay, when we understand the area of rectangles, it's helpful when learning about our factors. A rectangular area model is one way to represent this. So just pause right now, and I want you to think of how on this grid paper we can create area models for the number 16. When you're finished creating your area models, in which we did in the last lesson, I want you to unpause, and then we're going to go over the different ways that we can create that. So hopefully you paused. So I went ahead and I created area models for 3 rectangles with an area of 16. So the first one that I did was this one right here, and my area model is 1, and then there are 16 here. So one area model will be 1, the height of 1 and the base of 16. My next one I did was 2, and then my base is 8. So 8 times 2 is 16. 1 times 16 is 16. And the last one I did was 4 and 4. And we know that 4 times 4 is 16. So all of my factors of 16, well, I know that I would have 1 and 16, and I would have 2 and 8, and I'd have 4 and 4. So these are all of our factors of 16. 1, 2, 4, 8, and 16. Okay, so that's how we can use those area models. And I know that there's no other way I can do this because I have 1 times 16, 2 times 8, and 4 times 4. Those are factors of 16, and those are the only ones that we have. Okay, so that's how I know that I've created all possible rectangles with the given area of 16. All right, let's go ahead and erase my screen right there. All right, so the next one. So what we're going to do now is Sandy came up with the following rectangles for the number 12. So her first rectangle she created had the dimensions of 1 times 12. The second one were 2 times 6. So the base of 2, or sorry, the height of 2 and the base of 6. And then her last one was 3 times 4, which were her height was 3 and her base was 4. So we're going to list all the factors of 12. Well, we have 1, 12, 2, 6, 3, and 4. So these are all of my factors of 12. And if I want to, I can rewrite them in order from least to greatest as well. Okay, so you could write this. You could write it 1, 2, 3, 4, 6, and 12. So that's just a little bit nicer. I just pulled them from here, but then I put them in order from least to greatest. Okay? All right. So now what we're going to do is we're going to use our rectangles and Sandy's rectangle. So this is the one that we did together, our areas of 16, and our Sandy's rectangle is for 12. Oops. And we're going to put 2 of them together, of the rectangles, to make one bigger rectangle. Okay. So what I did is I went ahead and I put together, I did this one right here. So which 2 did I combine? So I did 2. And this one is 1, 2, 3, 4, 5, 6, 7, 8. And then this one, I picked one down here. So I did this one right here. And then I did another one. I think I did 4 and 4. 1, 2, 3, 4 by 4. No, yes. Which one did I do? Hang on, let me move this over. No, I did 3 by 4. I'm sorry. So I did 3 by 4. So this is a 3 and this is a 4. Okay, so what I did is I combined the 2 and the 8 and then the 3 and the 4. So this one and then the one right here at the bottom. I combined those 2 together. Okay, so we're going to go on to the next one and we're going to fill this in. So what we're going to do is we're going to do the dimensions of the smaller rectangle and then the dimensions of the second smaller rectangle. and then the dimensions of the larger, and then we're going to find the total area of what we're doing. So ultimately what we're doing is we're just combining one bigger rectangle from ours and then one smaller from Sandy's. So let's do the first one. Let me go ahead and change my pen color here. Let's do blue. Oh, let's do green. All right. So the dimensions of a smaller rectangle, 1. So we have this one right here. So we're going to put this in there, and you're going to see this exact thing as you're working. So my length was 1 times my width was 12. Okay, now the dimensions of smaller rectangle 2. So right here is this one. So we're going to put this in right here because this is our second rectangle. So 1 times 16. And you're going to see this exact thing while you're working through the assigned lesson today. Not everything from the lesson that you're going to see is going to be on my PowerPoint, but I want you to work through some of them by yourself. Okay, so now what we're going to do is we're going to take the dimensions of the larger, so we're going to combine these. So let's look at what they have in common. The length is 1 here, and the length is 1 here. So Sandy's rectangle and our rectangle have a common factor here of 1. So that is going to be the length right here. So I'm going to put a 1. Then I'm going to put times. Now W1 is this right here. So I'm going to put this 12. That's my W1. 12 plus then my W2, which comes from this one right here, 16. Okay. So we're doing a combine. So the length is the same for each of them, but then our width is going to be different. In the first triangle, it was a 12, and the second was a 16. That's why we took the 1 out, and then we have the 12 plus 16. So now the area 1, so we're going to use our distributive property. So we're going to show 1 times 12 is 12. Then we put that plus, and then the area of the second one. So 1 times 16 is 16. So we have that 12 plus 16, we combine it, and we get the area of 28. All right, so then the next one, I'm going to change colors on this one. So my second one, rectangle, is this right here for Sandy's. And then my second rectangle is this one right here for the one that we did. So I'm going to write 2 times 6 here. And then I'm going to write 2 times 8 here. Now, what's similar in these two? The 2. So that's what's going to be factored out. And then look at our width, 1, which is 6, plus our width 2 is 8. Then we're going to distribute this. So 2 times 6 is 12, plus 2 times 8 is 16. And if you notice, it looks very similar to this top one. And we combine 12 and 16, we get 28. So the combined total would be 28. All right, our last one right here, we get 3 times 4 from my first triangle, or sorry, rectangle, and then 4 times 4 from my second one. So what do we have in common here? We have a 4, so that's going to be what's factored on the outside. And then we have a 4 plus a 3, or a 3 plus a 4, whichever way you want to do it. Again, when we use that distributive property, 4 times 3 is 12. Oh, look at that, it looks the same. And then we have 4 times 4, which is 16. We combine those and we get 28. Okay, so if we notice, no matter which way we did this, and we factored out that common factor and then we added and we used that distributive property, our areas of the larger rectangle always come out to be 12 plus 16, and the area of the larger rectangle of the two combined always comes out to be 28. All right. So some things, consider any factors shared between your number and Sandy's number, which we talked about that. So here was 1 and 1, 2 and 2, 4 and 4. Those were common between the two rectangles. Common factors are the factors shared between the numbers. So something to think about are how are common factors represented in the larger rectangles that you and your partner created. So it's showing here that the factor that was brought out, 1, 2, and 4, those were the ones that were in common in both of the rectangles. 1, 1, 2, 2, 4, 4. And those were all the numbers that were out here. And then in the numeric expressions, like I said, those are the ones that were out here. They were common, so that's the one that we factored out. So what we could do now is list the common factors of the two numbers. Well, our factors of the two numbers are 1, 2, and 4. 1, 2, and 4 are our common factors because those are the ones that were in both the first rectangle and the second. And if you notice, 1, 2, and 4 are the ones that were on the outside and that we used to distribute. All right, so we are going to go through factor trees. Okay, so I did a little bit using those area models and showing distributive property again, which we did in the last one. So now we're going to look at factor trees, sorry. So this factor tree is showing the factorization of 30. So they did 2 times 15. Okay, so then 2 is prime, so they left it alone. And then they did 3 times 5, and then they got 3 and 5, those are prime. So pause right here and see if there's another way that you can create a factor tree, because there possibly could be a different way. All right, hopefully you've paused and unpaused. So there's actually 3. There's this way right here, and then we're going to do another one. Okay, so we did this one right here. 2, 3, and 5 end up being those prime numbers. Now we're going to try a different one. Maybe you did 30 and you decided to find 2 factors of 30, which were 6 and 5. Well, then 5 is prime, so we'll leave that one. And then maybe you decided to do 2 and 3. Okay, so 2 and 3 are prime, 5 is prime, so we're done. So this is another way. But if you notice, there's a 2 here, a 2 here, a 3 here, a 3 here, and a 5 here, and a 5 here. So we get the same prime factorization. The factor tree just looks different. The other one that you could have gotten was you could have done 3 times 10, and 3 is prime, so we're going to leave that one here. And then we're going to go ahead and find the factors of 10, which are 2 and 5. But again, 3, 2, and 5 are the same for all 3 of these. Okay, so you could have had a factor tree that looks very different, but they all have the same prime factorization. Okay, our goal is to get to those prime factors. All right, let's clear this one and go on to the next one. So you are going to now create a factor tree for 24. So pause right here and then complete a factor tree and then hit play and you can check your answer. All right, hopefully you went ahead and you paused that. I am going to do a factor tree for 24. I'm going to start with my 24. And I am going to do 6 times 4. And you could have done something different. There's other different ways. Now, 4 and 6, they were both composite. So I'm going to go ahead and I'm going to do 3 and 2, because 3 times 2 is 6. And then I'm going to do 2 and 2. So for 24, here's my factor tree. And I have 2 times 2 times 2 times 3. That is my prime factorization of 24. Now your factor tree may look different, and that's fine, but you'll have the same factors. You'll have 3 2s and you'll have a 3. All right, so let's talk about, that was kind of long how we had to write that. We had to do 2 times 2 times 2 times 3. So we can shorten that up. So each prime factorization in the previous question had repeat factors, which the last one that we did was a 2. So what we can do is we can represent the repeated multiplication as a power. A power has 2 elements, the base, and it also has the exponent. So if we look here, we have 2 times 2 times 2 times 2. We can do that. We can rewrite it as 2 to the 4th power. So 1, 2, 3, 4, 2 to the 4th. So this is the base right here, the 2. The exponent is right there. And then we're talking about the whole thing as the power. So the base of the power is a factor multiplied by itself repeatedly. And the exponent of the power is the number of times that you use that base factor. Okay, this is just a review. We have gone over this. So let's do some examples. I went ahead and put this here just so that you could have it off to the side. So we're going to identify the base and the exponent and the number below, and then we're going to write it in words. Okay, so let's see, get this. All right, so my base, if we look over here, is going to be 7. My exponent is going to be 5. So I'm going to write this in words. So what I could say is 7 to the 5th power. Okay. All right, so there's that one. Now let's look at the next one. My base is going to be 4. My exponent is going to be 8. And I could say this 4 to the 8th power. Sorry guys, my handwriting's a bit sloppy. Okay, so 4 to the 8th power. Okay. All right, so now what we're going to do is I'm going to do this first one and then I want you to pause and do the second one. You're going to write the prime factorization for 24 using powers. The nice thing is they already went ahead and they gave you the factor tree. So all you have to do is we have 1, 2, 3. So we have 2 times 2 times 2. So I can rewrite that as 2 to the 3rd power times, and then I have 1, 3 right here, 3. Okay, so go ahead and pause. And then once you finish doing this one right here, go ahead and hit unpause and you can check your answer. All right, so hopefully you unpaused. I have 3 times 3 times 3 times 3. So I can rewrite that as 3 to the 4th power. 1, 2, 3, 4. Okay. So when you write prime factorization, it's okay to write it this way, but we want to shorten it up. So if we can use those exponents, we're going to use those exponents. All right, guys. What your assignment to do today is to go through the lesson. There's a part 1, which I've done some of the questions for you, but I want to show you where you're going to stop. So you're going to see this on your lesson screen. I've assigned it for you in your Carnegie Math lessons. I'm going to put the link. It's going to be in your assignment. So when you get to this right here and you finish this question, write the prime factorization for 24 using powers, you are going to go ahead and you're going to stop and save your answer, and you can hit next, but you're going to stop. You're not going to go any further, and that should be on question 24. Okay, you're not going to go any further. You're going to actually no, sorry, you are going to finish the 3 questions on here, so 24, 25, and 26. But this is what it will look like. So you're going to finish questions 24, 25, and 26. When you get to question 26, you're going to save your answer and hit next, and then you'll continue. You'll finish this lesson probably tomorrow, okay? So when you get to question, let's change this. When you get to question 26, you are going to stop. Maybe if I can get there. Okay, so when you get to question 26, you are going to stop because there's actually 3 questions on that one. So you're going to do the prime factorization 24, 81, and then there's another one underneath of it. So when you get to question 26 on the lesson that I assigned for you today, save it and then submit it. All right. All right, guys, if you have any questions, remember I'm not available today because I am testing, but you can go ahead and send me a message and I will write back to you.